All right, go.
Hi, my name is Peter Ma. So I'm the creator for this project called Clean Water AI. It uses artificial intelligence to detect water contamination in pretty much real time.
That is so cool. So, why did you create this project? Like, what was the contest?
So I always create different type of projects for fun.
Uh-huh.
So Helium hosts a challenge called the IoT Without Limit.
Ooh, let's take a look.
Yeah, so I basically was very interested. I looked at through I submit a lot of different contests at for Hackster.io.
Sweet.
And this one I basically wanted to because artificial intelligence is kind of new, so I kind of really want to integrate artificial intelligence with the IoT space.
Cool. So, what did you end up building?
So I ended up building the project called Clean Water AI. I basically wrote down the guide, a step-by-step guide on how do you actually train the entire project, as well as how to utilize the entire, how to upload it to the cloud.
That's so cool. So, you're using a convolutional neural network, is that right?
Yep. It's a CNN neural network, and I just put down the guide on how to train this myself.
Wow.
Yep, and then basically run as well as inferencing through on the edge itself, so it doesn't really require any server that's being passed on during that time.
That's so awesome. Why did you choose to build this in particular?
Well, according to World Health Organization, there's over 2 billion. There's over like 200 million people are still basically drinking water that's contaminated, and I wanted to do something about this.
Totally.
I think detection is the first step, right? Because in water, it's people always ask, oh, why can't you filter the water? Filtering water has been out for like thousands of years. People filter water from sand, from stone. Groundwater is type of water that's being that filtered itself.
Right. So, you're bringing AI into it, sort of modernize this.
Yeah, because the idea of using AI is still relatively new.
Uh-huh.
Right now people mainly kind of tracking for people's emotions as well as using the neural network out there to tracking for things like parking and stuff.
Mm.
What I want to do is that take a little step further, and this is the thing is currently pretty much all of the water sensors are basically chemical based. The most
Mm.
commonly being used are those test strips that you dip in the water and then
Right.
you get the results back, which is great for chemical. But whenever new bacteria comes out, it becomes not efficient enough
Right.
to do that.
You have to distribute the new strips after already formulating
Yep.
them and so.
That's really okay for first world countries,
Uh-huh.
but in third world countries, this is why I traveled over 36 different countries in past 2 3 years,
Dang.
and I get sick a lot, and that's part of the reason why that these are there's contamination around.
Mm.
But if you can detect where the contaminations are, you can easily stop the contamination, give everybody else pretty much a clean water.
So this is something that you could leave on a site, but you could also take it with you as a traveler to kind of
Uh,
check on stuff.
yeah, well, the technically the traveling the test strips become a little more
Right.
it becomes a little more efficient because you're carrying the strip with you. They're
Don't
light,
need any power.
but this is more eventually I want this to be part of like a smart city where it's just leaving on the site where it can monitor all the time.
Uh-huh.
When the contamination spreads, you pretty much can see that through the mapping.
Super cool. So what in your background led you to this point? Do you have a history of working on this type of project, or where you're coming from?
So I do rapid prototyping for a living.
Uh-huh.
Whenever I'm working, I have to work for clients for different type of projects. Whenever I'm not working, I'm basically working on my own project like these.
Right.
Part of the Intel software innovator, so they support me with a lot of hardwares
Nice.
to work on projects like these.
That's sweet. So how does this work? We've got this helium unit down here,
Hmm.
which you can't see, but it is feeding information or a video from this microscope to a monitor, and let's take a look at that.
So this is basically the essentially what it does is through this device we're gathering the information coming from the microscopic camera. We're inferencing that through the AI, and we're getting all this data. Through the the helium atom, we're basically sending that directly into Helium Hub, and then that's connected to the Google Cloud, as well as all
Cool.
the other IoT cloud platform.
Ah. So we have this local display on this monitor, but it's also streaming the data to the cloud.
Yes.
Neat.
So let's do a little demo.
Yeah.
This is just a little Arduino pump that I built because I couldn't buy one. It's gonna take a little time.
It's like a
And now we're gonna,
peristaltic pump with
yeah,
vacuum.
but so now we're gonna basically pumping some more water with yeast. Let this sit down.
So that was clean water, and now you've pumped in the yeast.
Yeah, and now I
Cool.
pump in the yeast water. Let me see where the yeast are.
Focusing. Whoa. Gotta find them. Gotta find those yeast.
Well, because when they're flying around.
Right.
And when they settle, that's why I was just now I was playing with cold water.
Oh, yeah.
Yeah, I don't think this yeast concentration is a lot. Oh, that's why. Hold on. So eventually what I'm trying to do is basically get rid of this entire microscope so that we can, wait, where are the yeasts?
I'm really curious to see what they look like.
On the water scale. Oh, okay, now you can see they're still flying around. They're still flying around, so we kind of have to wait for them to settle down a little more.
Hey, yeast, chill out. That's so cool. And you're sort of focusing at different depths in the water?
Yeah, so eventually this will be one single depth where the water pumps in as well as being pumped out.
Right.
Hold on. This may be a little too much water.
Oh, there we go.
Those are the yeast around, but they're not cluttered right now.
Ah.
As you can see, the yeast jumping around.
Cool.
As they settle down, we'll have a little better angle. That's what's easier. I can bring another petri dish. It's probably a little easier if I just bring another dish. That's
right. That's over. Like emptier.
That's a lot more emptier.
Cool.
Okay, hold on 1 second. This had a little too much water earlier. Right, so if we pump, so from the clean water to pump a little bit of yeast water in here. Okay, now we can focus down. Cold one's a little better to work with.
Because they're not as active?
They're not as active. Right now they're jumping around. All right.
Whoa.
Hold on. Let's see if we can go down a little deeper. The table is a lot more shakier.
Oh, yeah. It's a 3-story, 4-story building, so we have a lot of very mobile neighbors.
Hold on, give me 1 second, okay? Yeah. Wow, it took like one shot in my house. That's why I was like. So if we just distribute this around.
Yeah, there's a lot of construction around here too.
We can distribute this around.
Whoa, cool.
These are basically layers of yeast.
Wow.
As you can see now, the water becomes contaminated.
Yeah. So gross. You're not gonna drink that, are you?
If you look at the, so we use this, we use a couple map system, but currently we try to basically use this map from NASA.
Cool.
As you can see, this.
Oh wow! So that was showing that the water went from clean to contaminated in this one spot.
Yeah, that's so. So if we basically location-wise, if we basically attach the attach the entire thing to the location, this is how we will be able to see when it's clean, you know. And when they get contaminated, right? It's basically the map will basically reflect the exact location where the clean waters are, as well as where all the contaminated water. This way, people can travel around to see where this stuff are. And now see that when the yeast settles down. when they stop flowing. That's the next part of the project. We're basically gonna have a stop floater.
What?
We're gonna build a device basically so we can pump in the water, stop,
Oh,
and
so
then
it stays still.
yeah, and also the another reason why is bacteria grows, right? You have to wait until they grow. So this is where and then when it refreshes every day. Once we start seeing contamination, then you have the water inspector come in. This way, it speeds up a lot of their work as well as empowering them to do a lot more locations rather than what we're doing today.
That's really awesome. So, you mentioned that you want to add this, did you call it a stop flow mechanism in there? What other plans do you have for the future of this project?
So the very next step is basically getting rid of this entire microscope.
Right.
We you can take a picture of that later. Like
Cool.
that's so the entire device
It's
and
like a
IoT
cool new
device will
unit.
be in one unit. All you really have to do is connect the water pump from one end to the other, and it will automatically basically recycles water every, to the testing area every 24 hours or so. This way, when user can basically directly stream into to see what's in their water first of all, and when the AI picks something up, they will basically give them warning as well as the photos through the IoT devices.
That is so cool, and plus, like regulators can see this stuff on the map too.
Mm-hmm.
So you're using Helium to pipe all this data into the cloud. How was your experience working with that?
The experience is great. As you can see, this device is not connected to internet in any way whatsoever.
No, I know that because the Ethernet port is like 25 feet away. Believe me. Okay.
So this allows us to basically implement multiple devices for smart cities as well as for smart homes. Eventually, people can just embed the device, and and then all the information will basically transfer through the through all the cloud services like Google Cloud Platform.
Sweet. And what's the range on this guy? Like, we're a very decent distance from the router.
Technically, they can do up to like a mile.
Dang!
So, this is really great for smart city. Basically,
Yeah.
with the correct mapping, this will reduce, all the hassles on, all the IoT devices will be connected without limit.
Oh, yeah. Oh, you got the name of the contest in there. It's so good. Speaking of which, let's take a glance back. Oh, wait, no, back here. Those yeasties are totally moving around there. Okay, back to the contest real quick. So there were a couple other projects we wanted to highlight real quick. The second and third place were also smart cities type of things. We had a cool sensor node that's got a bunch of sensors on it, like temperature and humidity and barometer, and it also tells you its battery measurement level thing. And then one that gathers data on common bike routes so that they can plan where to put bike share services and things like that. So I definitely recommend checking out the rest of them. Are there any other favorites that you had among other ones that you saw?
I really like the bike route one. I actually saw a recent Vice interview. Somebody actually got a grant through doing the air quality measurement in the entire New York City for bikers.
Whoa!
And I was like, wow, hey, there's a project that's we're actually building an open source project.
Sweet. They put the sensors on the bikes?
Yeah, they put the sensors on the bikes, and then they basically put they invited 60 different bikers.
Whoa.
And then they would basically see which part of the bike route is the best for which part of the bike route is best for biking to work, and because of the air pollution that you're inhaling in, because and that was a study they said. I'm like, hey, this is a project that can easily integrate something into that, not just as a research project, but as actual add-on to your bike, where so people can actually share the data and understand that the air that they breathe, it's the best air through the bike route.
So
I thought that was really, really cool.
Cool. Do you have any plans to build anything like that, or are you just gonna admire it?
Well, if I have time.
Yeah, totally.
If I have time, I'll probably build something like that. And then I know Paul personally, so like. Yeah.
Sweet. Congrats,
I'm
Paul.
I'm probably gonna add on to his, tell him that to add on, just because it's pretty simple. Just add on another air quality sensor.
Hey, Paul, you should add this.
Yep.
Nice.
Yeah, and then there's already research. Somebody already got like I think somebody that's like a $60,000 grant that they already got this to do this project.
Sweet.
And so there's definitely demand for bikers that want to know what air they're breathing through their bike routes.
I mean, I commute by bike and I use the jump bike or the city bikes in New York. And on the one hand, I do want to know, and on the other hand, I really don't want to know. Just like, I don't know. But that's fantastic. Any last things you'd like to put in here before we break off?
So this entire project is open sourced,
Uh-huh.
from all the way from training the AI to deploying the AI, to connecting AI with IoT through Helium.
That's
So
so cool.
Helium made it really simple that you no longer have to write your own protocols
Uh-huh.
for connecting with the different services. It's sort of a all in one type of device, which just made your life a lot more easier. So next step obviously is reduce price of the unit, as well as
Mm.
build out the actual project where to so that it can become one single independent device, and
Yeah.
hopefully embed that, open up a Kickstarter campaign, and
Oh, yeah, we
implement this
do.
into people's lives.
Ah, we would love to promote that. Yeah, and it's totally open source, and we can tell that it works because not only did we spend a bunch of time setting it up, which was awesome, but you can even see it on GitHub. Do you actually want us to show this?
Oh, sure.
Cool.
I basically integrated with multiple different functions, as well as using NASA's map.
Ooh, nice
So
logo.
this is where this is what Sarah helped me to build the logo. So
Sweet.
this is basically using the NASA's map. You can embed around, and yeah,
Wow. And then there's
it has
also
a
a
little more
Google
features.
version.
There's also a Google Map version as well, where you can you can integrate.
Cool. So many features.
Yep.
This is so cool.
I'm basically trying to find the
Oh,
cheapest route of getting everything, because NASA's map is, taxpayers pay for it, so it's free.
yeah. Awesome. Well, that is an awesome use of. This is an awesome use of citizen science, and this is an NASA's map is an awesome use of taxpayer funds as well, I think. Well, thank you everyone for entering the contest. I sure hope that you check out the Clean Water AI project. It is so cool. Like, I can't get over this. I don't know, it's super neat. Thanks so much, Peter, for coming in. And also, secretly, we have a couple people from the Helium team in the office as well who are like hovering over there, and they're super cool too. So, thank you, Helium team. Thank
Thank you,
you.
Helium team, for creating such an
Yeah.
awesome product that I actually demo these outside of the contest.
All right, awesome. Thanks, Peter.
Thank you.
Thank you for watching. Have an awesome day. All right, what I think we're gonna do is transition into questions soon here. Peter, are you good to go for that?
Yep, I'm here.
Sweet. Cool. Let me see if I can turn on some video here. Not yet. All right. Well, anyway, so Peter, you mentioned that you're thinking about doing a Kickstarter, maybe. Have you thought about other opportunities for or other places in the world to deploy clean water AI and helium? You mentioned that you travel a lot.
So first, like I would actually start internationally with this. First, probably gonna be somewhere around Dubai,
Hmm.
and also a couple of cities in China, because they're like really into smart city. Where people want to know where everything is in their city. And then after that is basically cities like Flint, so that because there's
Yeah.
already having a problem, it would create a lot more transparency to the cities. And after that is basically deploying that into directly to people's house.
That's a
That
great point because you hear about Flint and you don't really know if any progress is being made. And, maybe someone comes in like Elon Musk or whatever and says like, I'm gonna fix this, in X amount of time. And you're like, well, is he actually doing it? I don't know.
the because I did a lot of study into water industry like lately.
Mhm.
The water sources, first of all, you have to figure out like where the contamination is from the water sources. Once that happens, you can kind of stop like the contamination from there, and then the water become clean again until somebody else contaminates it. But to install this is more of a fail-safe device. Is more of a constant monitoring, rather than it's like, oh, I'm gonna go filter all the water in the city, because that's what people's first mindset is. Oh, let me just filter the water, but that is expensive. And it's also a very large project if you want to filter like entire lake of water. That's
Right.
almost impossible to do, because water itself is kind of filtering factories in one way.
Whoa. What do you mean by water itself is filtering factories?
Basically, like we use water to clean up the factory, a lot of
Oh,
byproducts, and
yeah.
then flush them back into the river, and
Right.
then which eventually end up being the lake.
So, but if you can find out which factory is doing these, then you can instate more regulations on the factory, so that their normal citizens' water don't get contaminated.
Yeah, and then the taxpayers and everyone doesn't have to spend as much money to clean it up, and like they can distribute it better. That is so cool.
Yep.
Besides, so you've done a ton of research into this, obviously. I can't imagine how you managed to like work on multiple projects at the same time, but you did work on two other projects for this contest, right? So can you tell
Yeah.
me a bit about those?
So one of them was basically monitoring the entire city's pollution. That one I did it it's kind of my first project dealing with helium, because you need a Hello World project to figure out what you're doing,
Right.
um, because just to learn the technology. That's kind of what I do with almost any new technologies that I dealt with. And also it was kind of on Arduino, so because it was on Arduino Uno, so it was one of the most primitive form of IoT device. Um, so then if I can't even do that, then it's really hard to move forward. And the second project that I did was called the AI Vision IoT. That one is because I'm like, this is actually the next step of clean water AI. I'm trying to train the entire different bacteria so that I can do object detection rather than just a simple image classification. That method is a little more difficult to do. I'm still kind of learning how to do it, since when you reach to a point where you can't find any guides on the internet anymore.
Yeah.
um, you kind of have to do a lot more digging and then tinkering yourself. But first, that was one of the samples I was using just to figure out what was going on, and how to play with a technology called the single shot multi-box detection.
Whoa, single shot multi-box detection?
Yep, that came out like around 2 years ago, and it's been pretty popular lately. There's two type of object detection using the deep learning neural network.
Uh-huh.
Well, to popularize, one of them was the YOLO. Uh, it's not only you, but one of them is called YOLO. But YOLO is kind of slow in terms of performance because of the amount. It's basically you trying to box out everything, and then you run image classification on each one of those boxes.
Mm.
Um, no, but what happens is that naturally slows down the entire process because you're, instead of running one image per 4 images per second, you need to run you basically every image is divided up to almost like 9 to 12 images, depends how you do
Wow.
it. So that's a little more difficult. And the single shot multi-box detection is like a kind of new. Um, so it greatly outperforms YOLO in a lot of ways. That's kind of a thing. That'll be my next article on how to train your own single shot multi-box detection.
Wow, awesome. As a side note, I've heard of people starting to use FPGAs to speed up the YOLO version of it because you can run all of that in parallel, but
Yep.
having an alternative definitely sounds awesome.
FPGA is another technology that's been kind of like popularized because I like when people talk about AI right now, like they kind of use it as a buzzword
Right.
rather than like they like most people have no idea what's going on. But like the AI and computer vision kind of increases, like before 2012, the computer can't even doesn't even know what a cat is.
Uh-huh.
So right now, what the difference is that once that breakthrough was out, right? Like computer finally figure out, through deep learning neural network, basically back then, it's just considered machine learning. When that breakthrough came out, is that now computer know what a cat is. But once computer know what a cat is, you can know what a dog is, you can know what a horse is, and then you can know what a contamination is, as well as which part of the airplane is broken. And
Right.
that's what AI is really about. That's what the buzz is about. But nowadays, people call everything AI, from just a simple big data to statistical analysis and prediction, which is kind of not true because they try to get the buzzword in just to make their project sound cool. um,
Totally.
but
Well,
once you understand what AI can do, which is just deep learning neural network, there's almost endless possibilities. The entire self-driving car is basically built based on that.
mm. And it's true though that even for most people who are starting out in AI, it's sort of a solution looking for a problem, and you seem to have definitely found a good problem that it can like really help address. Have you thought about other uses for AI with helium besides clean water? You mentioned air quality for one.
The air quality, so air quality wouldn't use AI because the amount of microscopic camera becomes a little
Right.
uh, little, how would I say this, like we can't really see what's in the air.
No, yeah.
This is where chemical sensors become a lot more useful. But with the other
Oh.
project is basically using the AI vision. Just about a couple of years ago, there was a startup that raised almost $20 million on figuring out how many customers there are in your store, right?
Mm. Mm-hmm.
And that was like a very high tech, like kind of their proprietary technology. But today I can do that, like in AI vision. In AI vision, the project that I did, you kind of can do that with almost $20. Well, not $20, like $100 worth of material.
Yeah, that's so cool.
So you can do that. You can detect where people are and how many people are. That's just a very simple use case of how, but you can see how useful it can be and how cheap it can be to deploy something.
That is so cool. And hopefully, like the next generation of helium products and projects is going to be just helping make that easier. I don't know. Are you excited about anything particular in the future of what people are going to be doing with helium?
So the Helium's next version of the product is very, very interesting. It basically uses transfer of data as tokens. So
Huh.
to yeah, um, so it's basically complete decentralized in a way where people have a in a way this is how internet was supposed to be built. Because it's meant to be shared. It's meant to be it's meant to be nobody owns it. So Helium
Hmm.
to at full vision, I think Helium can completely change the internet, like how the show Silicon Valley basically says the entire decentralized internet.
Mm. Yeah, I've
Because
heard a couple of other propositions for decentralized internet. I'd love to hear more about this if you have more
yeah,
background on it.
yeah, so from Helium's perspective, it's like first step we can basically transfer of a simple snippet of data.
Hmm.
The very next step we can transfer little things more like images and stuff like that through the hubs, right?
Right.
And the step after that we can actually just attach server directly into the Helium network or decentralized network. And then the
Huh.
step after that, we don't really need to connect to internet anymore. We simply can just connect to each other
Yeah.
uh,
Once
and
you have
gather
enough density.
and then basically transfer the tokens can be used can have a lot more usage.
That's so
So,
cool.
so imagine I'm taught like we're hosting this entire talk just on your own computer, right? And other people have access directly to your computer and they
And
pay.
so, like, if you had enough people sort of around the world, then you get enough density for like a mesh network so that you could all.
Yeah, localized mesh network. In terms of the redundancy, there's a lot more problem that's going to come up. But when you reach that point, those are not bad problems to have.
Totally. Yeah, yeah. I'm a huge believer in good problems.
Yeah, when you have that, when you can completely decentralize the internet, those are there's going to be a lot of there's going to be a lot of problems that are going to pop up. Like how do you make sure the files are complete secure? How do you make sure the files are redundant? How do you stream videos? Because it's no longer peer to peer. You have to figure out how to do one to many. But
Right.
we have to reach that point first.
Yeah. I've heard
So
of
that
ways of doing security via just hashing everything and comparing the hashes, but that also requires a little bit of expertise or a little bit of better UI.
But first, we have to completely centralize the internet first. Uh, and so far, it's kind of just a fiction where Pied Piper's doing it on the show.
There's a group called IPFS that's doing something similar, but I want to see the Helium version. I bet it'd be like there's this whole beautiful UI and everything that's already stacked up and ready to go.
Yep.
Super cool. Anything else you want to throw in there before we wrap?
Um, the about what would you like to talk about?
What are you excited about? It could be anything.
Well, the next version. So for AI right now, we're looking for the next big breakthrough.
Hmm.
Um, So right now, the thing is AI have two things that we're kind of waiting on. First is basically the unfolding, right? So if you train it using exact same data, if you copy two files, the two files will be exactly the same, right?
Uh-huh.
And if you compile two programs, the files pretty much almost exactly the same too. Like the first program equals the second program. But if you train the AI, the first one, it doesn't necessarily equal to the second one yet.
Right.
Right. So waiting on two things is the first you unfold of that, right? And because it's kind of right now it's still a black box.
Hmm.
You simply know the prediction, but you don't really know how it's coming by that prediction. How do you recreate the exact same model that gave you the exact same logic? So
Right, and you don't know exactly what it's training for either. Like you think that it's training for, people on the platform, but it's actually training on the clock on the wall for like detecting how many people are around. It's that like you
yeah,
don't know what it's looking for.
yeah, it's the parameter is basically set for you can only set basically edges and contrast. So like you kind of don't know where it's looking for that. Yeah,
Mm,
it's you set the parameters. Oh, look for these boxes, but how exactly it's doing, we still don't know yet because we can't kind of retrain the exact same model yet, right? There's the first model
right,
does not equal the second model. So
right,
once
right.
that's being done, that will give us a little more breakthrough for the medical field, how AI is going to run
Ooh.
in medical field. Another project I'm working on basically using AI to detect skin cancer, and we run into
Wow.
FDA problem is like FDA requires transparency and
Oh,
certainty, because of if you can't recreate the exact same model, then that's not really transparent.
right.
Right. And the second thing is like the AI right now still doesn't know what it doesn't know. Like with a couple pixels, you can kind of manipulate the entire data,
Hmm.
right?
Yeah, so
So
you get those generative adversarial networks where you can like create adversarial images and stuff that look to it like a rifle, but to us like a tortoise or whatever.
yep. So if you train based on a dog and then you train on a cat,
Hmm.
and when you see something like a horse, it doesn't really know what it is, but it will say, "Oh, I'm 60% confident this is a horse, and 40% confident this is a cat." I mean, that because it's neither. So we're kind of waiting on that. So this way, like something like because like when a new type of bacteria flows through, we're like, okay, I don't know what that is. I'm gonna record it, and somebody else can come and expert can come in and see the sample and take the sample and do something with it.
Right, so it can go like, this is some new thing that I've never seen before.
Yeah, because in world of biology we constantly see new superbugs and stuff like that.
Yeah,
That's
which
kind of
is, scary and also cool. I don't know. This stuff that you're working on is so cool. You mentioned that you're trying to train on a broader set and be able to open source that. Are you planning to share the trained models that you come up with based on the data that you gather? Um,
Yep, that's the whole point. Also, like eventually, like each area would have we can localize the model as well. If we know
oh,
area is basically heavily contaminated with E. coli, then we can basically specifically train different type of E. coli around that area.
wow.
In the United States, we no longer have cholera problem. Like that doesn't really like we kind of don't need certain type of bacteria,
Mm.
because the less categories, the more accuracy it becomes in the deep learning neural network.
That makes total sense. So if it's training between 5 different kinds of E. coli versus like E. coli, cholera, diphtheria, whatever.
Hmm. But we can go up to like 1,000 type. But the thing is, we can like become localized and specialize in specific area. That's what also make great about using AI over different type of sensors.
Hmm.
Well, I wouldn't say like great, but it was like this is more different, and that some advantages using this because we can basically do this based on what people need and based on the data that's provided in the specific area.
Well, I think what you're doing is really amazing. You're not just, you mentioned before that you do rapid prototyping for hire basically, but you clearly have this huge focus on pro-social and like pro-humanity causes as well, and I just really respect that. Thanks so much for talking.
Thanks. Well, I mean, it came down to like end of the day, can you create a product that's actually can help people and then people actually need and it solves the problem.
Yeah, there's always
Um,
going to be need for that.
yeah, I learned that from what this guy who make mushrooms. He builds mushrooms to replace styrofoams. And
Wow.
so he's getting paid by the government to keep researching it and to build the product to sell to companies, and then he's getting an award for it. I'm like, wow, this guy is awesome. This is like, you need, whenever you think about business, you have to think about it like all these angles.
Mm. Yeah, it's a dream, right? That's awesome.
Mhm.
Well, thanks again so much for talking. This is so cool. Like, my brain is going to be buzzing for the rest of the day. Thank you, Helium team, for hosting us. And thank you all for joining in and listening. Ciao.
All right, thanks everyone.